we are going to simulate two amazing magical circuits. Number one, negative impedance converter, and number two, a gyrator circuit. Let us see them one by one. First, a negative impedance converter. Now, what do you think when I talk about a negative impedance or a negative resistance? Suppose we have a black box with two terminals, one here and another is a common ground. Between these two terminals we have a piece of resistance with value R. This value is not known to us and we want to measure this from outside. For that, we can take a voltage source with known voltage V plus minus and connect the negative terminal of the voltage source to the common ground, and the positive terminal is connected to the input of this black box circuit. Then we will measure the current I flowing into this black box circuit, and for that we can use an ammeter in series. Make sure to connect this ammeter in a way so that it measures current in the direction from left to right. Then we can estimate this resistance R as the ratio of the voltage applied divided by current flowing. Make sure that when you have applied positive voltage here, you are measuring the current in the direction from left to right. And this ratio V by I is this resistance, which we will call as the input resistance of this terminal. That is the resistance between this terminal and the common ground. Now, what if the ammeter reading comes out to be negative? That means the current is flowing actually from right to left. That means from inside to outside, while voltage amplifier. A voltage amplifier, which we will denote with a triangle like this, is itself an electronic equipment which has one input terminal and one output terminal, such that if you apply a voltage to the input, call it V in T, then this amplifier will produce an output voltage V out T, which will be equal to the input voltage multiplied with some constant K, and this constant K is called the gain or amplification factor of this amplifier. We may also write inside this triangle the value of the gain or amplification factor. So, an voltage amplifier simply takes one voltage input and produces a voltage which is same as the input multiplied by some constant gain or amplification factor. Note that here while mentioning this input and output voltage, we are measuring all these voltages with respect to some common ground. So you may connect your input voltage source like this between the common ground and the input of your amplifier. This is V in t, function of time in general, and the output voltage is also measured with respect to the same common ground. This voltage amplifier, which we are denoting with just a triangle, this itself is an electronic circuit with its own power supply and reference or common ground, which we may show like this if you like. Now, one very important property of an ideal voltage amplifier, which you must understand and remember, is like this. This current, call it I in will be equal to 0 always, no matter whatever voltage you apply to the input. That means no current can flow into or out of the input terminal of an ideal voltage amplifier. So, in summary, a voltage amplifier reads a voltage which can be a function of time and produces a voltage which is same as the input multiplied by or amplified by a factor of k. However, the voltage amplifier does not take any input current. That is true for ideal voltage amplifiers, and for practical amplifiers this current will be negligible. Now, using the concept of a voltage amplifier, we will make an electronic circuit which will have a negative input resistance. Consider a black box which has one input terminal. Here we have a piece of resistance R connected, and here we have an amplifier with gain 2. The input of the amplifier is connected to this side of the resistance, and the output is connected to the other side of the resistance. Now we want to measure the input resistance of this terminal with respect to some common ground, which will also be the common ground of this amplifier. So for that, we will take our voltage source V plus minus. We will connect it like this. We will apply the positive terminal of this voltage to the input of this black box, and then we will measure the current I that flows into this black box from left to right, and then the input resistance will be equal to the ratio of this voltage divided by this current measured in the direction from left to right. Now let us estimate this current. So this current will be same as this current plus this current. However, this current is 0 because no current can flow in or out of the input terminal of an voltage amplifier. So what will be this current? Okay, notice that the voltage here is V, so this voltage is also V, This voltage is also V. So here we will get a voltage of 2V, which will come here, and therefore here we will get a current in the direction from right to left with value 2V minus V divided by R, that is equal to V by R in the direction from right to left. Therefore, here I can say I is equal to minus V by R in the direction from left to right. Thus, the input resistance will be V divided by I, which is minus V by R, that is equal to minus R. Therefore, the input resistance of this black box is negative. That is amazing. That is magical. Next, we shall see a gyrator circuit. What is a gyrator? It is a black box or a two-port network which has two sets of terminals or two ports like this, where you can apply two voltages like this, V1 and V2, with respect to a common ground. And then you will get currents I1 and I2. Now I1 and I2 will definitely depend on V1 and V2. But for a gyrator, the relationship between these currents and voltages, it something funny. I1 depends on V2. It is like I1 equal to V2 by R, where R is a constant with the dimension or unit of a resistance. R is a property of this gyrator circuit, and the current I2, that will depend on the voltage V1, like V1 divided by R with a minus sign. The constant here and here are same. Notice that in one of these two equations I have plus sign, and in the other I have minus sign. It could be in the opposite way also, that is minus here and plus here. Anyway, please notice the polarities of these voltages and the directions of these currents that I have shown in this diagram. You may also write these two equations as V2 equal to RI1 and V1 is equal to minus RI2. So V1 depends on I2 and V2 depends on I1. Now what can we do with this gyrator circuit? We can turn a capacitor into an inductor. Sounds funny, right? Let us see how to do that. We will connect a capacitor here in this port 1, with capacitance value C, and then let us consider this capacitor together with this gyrator as a single black box. Then we want to measure the impedance of this black box between this terminal and the common ground. For that, we have this voltage source V2, and we will measure this current I2, and then we can write the impedance as seen or measured from this port between this terminal and this terminal is given by this voltage V2 divided by I2. Now V2 is given by RI1 and I2 is given by minus V1 by R. So this is equal to R square I1 by V1 with a minus sign, and V1 is this voltage from here to the ground, with this side positive and this side negative as the reference polarity, and this current in the downward direction is minus I1. Therefore, I can write that V1 is equal to minus I1 multiplied with the impedance of this capacitor, which is 1 over Cs in Laplace domain. Okay? Then here I can write this as minus R square I1 divided by V1 is minus I1 divided by Cs, like this. Now minus minus goes away, I1 goes away. So we have R square Cs. This looks like the impedance of an inductor with inductance equal to R square C. If we define L equal to R square C, then this is equal to Ls. So therefore, as seen from this port, this capacitor together with the gyrator will behave like an inductor, although there is no inductor in this black box. That is really surprising. Now we shall see how to realize a gyrator circuit with amplifiers. This is the black box of a gyrator with two ports having voltages V1 and V2 and currents I1 and I2 as shown here. The relation between different voltages and currents should be like this: I1 equal to V2 by R and I2 equal to minus V1 by R. We have to realize these two equations by filling in this black box with amplifiers and other elements appropriately. So let us look at first any of these two equations. Say I look at this equation and I want the current I2 to be equal to V1 by R. So I can take a resistance with value R and I can connect it, say, between these two terminals like this. Then this current I2 will be equal to voltage V2 minus voltage V1 divided by this resistance R. However, I want I2 to be equal to minus V1 by R. We have minus V1 by R here, but we have V2 by R extra. So we will try to eliminate this term V2 by R somehow. For that, I will take an amplifier like this with gain equal to 2 and I will connect it with a resistance R, and the other terminal I will connect here. Then what will happen is this voltage is V2, so this voltage here will be 2V2 and therefore this current will be 2V2 minus this voltage which is V2 divided by R. Therefore this current, which is this current, is given by V2 by R. Okay, this is V2 divided by R. So therefore this I2 will be equal to sum of these two currents. Here we have V2 minus V1 by R here, and this current I will take in the opposite direction, minus V2 by R. So this is equal to minus V1 by R as we wanted here. Please note that this current is 0 because no current can flow into or out of the input terminal of an ideal voltage amplifier. So in this way we have realized this equation. Now let us see whether we can realize this other equation also. Right now this current is V1 minus V2 by R, V1 minus V2 by R, and we want I1 to be equal to V2 by R. So let us first turn this minus V2 by R into plus V2 by R. So for that, let me take an amplifier. Connect it from here. And then the output goes through our resistance R back to here. Okay. Now, if I take the gain of this amplifier to be equal to -2, then this voltage is V2, so this voltage will be -2 V2, and here we have V1, so this current will be equal to V1 minus 2 V2, so that is plus 2 V2 divided by R. This is this current. Now we have I1 equal to this current plus this current. This is V1 minus V2 by R, and here we have plus V1 plus 2 V2 by R. So together this is equal to 2 V1 then plus V2 divided by R. Now this V2 by R is same as what we want here, but 2 V1 by R is extra here, so we have to cancel this term. So for that I will take another amplifier like this. The input will come from here, that means V1, and I will connect the output through our resistance R back to here. Then this current we have to adjust by choosing proper gain of this amplifier so that this term is eliminated. Now if I take this gain to be equal to 3, then this voltage here is 3V1, and then this current will be 3V1 minus V1, 3V1 minus V1 divided by the resistance R. So this is 2V1 by R in the backward direction. So let me add this current here, minus 2V1 by R. Here also minus 2V1 by R, and that will give, these two will cancel and we will have V2 by R as desired. So in this way we will get I1 equal to V2 by R as we wanted. Please note that this current is 0, this current is also 0. Okay, so you may possibly fill in this black box in different ways to realize these two equations, I1 equal to V2 by R and I2 equal to minus V1 by R. Okay, so we need amplifiers to make either a negative impedance converter or a gyrator. Now we can make amplifiers using something called op-amps. Op-amps are small electronic ICs. Now I am not assuming that you know about op-amps. Neither I will try to teach you about op-amps in 5 minutes or in half an hour. That will be a foolishness to try to understand op-amps in half an hour if you do not know them already. I will just tell you how to make an amplifier in a simulator and then use that amplifier to make a negative impedance converter or a gyrator. Okay, this is the symbol of an op-amp. It has two input terminals which are denoted with plus and minus sign. These two are inputs, and it has one output terminal. This itself is an integrated IC, and therefore to work op-amp requires power supply, and that power supply is to be connected to these two terminals or pins. Here we will connect the positive supply voltage and here the negative supply voltage. Okay, now let me tell you how to make an amplifier with an op-amp. First thing we will do, we will give power supply to the op-amp, plus 15 volt and minus 15 volt. You can use plus minus 12 volt supply if you like. Then take two resistances like this, R1 and R2 in series, R1, R2, connect the other end to the ground, and this point you connect with the minus input terminal. Okay, and then here you can give input voltage, and here you will get output voltage. This will act as an amplifier, with this terminal being the input of the amplifier and this terminal being the output of the amplifier. Now for this circuit, the gain or K of this amplifier is given by 1 plus R1 by R2. Okay, so by changing these two resistance, you can make your amplifier with suitable gain that you like. Next, we will make another kind of amplifier with an op-amp. For that, first give power supply plus minus 15 volt to the op amp. Then we will take our resistance and connect it like this. Call it R1 from the output to the minus input terminal. Okay, and then we will take another resistance and connect it here. Call it R2, and this terminal, the other input, positive plus input, that we will connect to the ground. Okay, then this circuit will act as an amplifier, with this being the input of the amplifier and this being the output of the amplifier. The gain of this amplifier, that is K, is given by the ratio of R1 and R2. R1 by R2 with a minus sign. Therefore, the gain of this amplifier is negative. If you give positive input voltage, you will get negative output voltage. And the ratio of output voltage by input voltage, that is the gain, is given by this ratio of R1 and R2. So this amplifier has negative gain, and you can change the gain by changing R1 and R2. This amplifier has positive gain, and you can change the gain by changing R1 and R2. Now, a very important fact we should know before we can proceed is that this amplifier with a positive gain is like an ideal amplifier, where this input current is 0. However, this amplifier with a negative gain is not like the ideal amplifier we have discussed, because here this input current can be non-zero. Okay, so this amplifier can draw current from the input, but this amplifier will not draw any current from the input. Now, in this gyrator circuit, where we need an amplifier with gain minus 2, we cannot use this particular structure or architecture of the amplifier, because it is not like an ideal amplifier with 0 input current. So if we use this particular architecture here, then it will draw current from here, which we do not want. So what can we do? One solution is this. We can use a combination of this positive gain and this negative gain amplifier, like this. Suppose I take a positive gain amplifier with gain equal to 2, where the architecture of this amplifier is like this. So this amplifier is made with this particular structure. Okay, so this is like this one, and then we will take a negative gain amplifier with gain equal to -1, and this amplifier is made with this structure, this architecture. Okay, so this one is like this. Now let us connect them in cascade. So output of this amplifier goes to the input of this amplifier. Now these two amplifiers together in cascade will be equivalent to one amplifier with gain equal to -2. You see that this amplifier will make this voltage double here, and then this amplifier will make this voltage negative. So overall gain of these two together will be equal to 2 multiplied with -1, that is -2. However, since this amplifier, which is like this amplifier, does not take any current from the input, so here this current I is equal to 0. Therefore, here also this current is 0. So we can use this cascaded combination in place of this amplifier. We should not use this structure alone, because then it will draw current. I will show you how these two amplifiers work using a simulator, LTSpice. This is LTSpice. I will open a new file and then go to components and search for op amp, and then select this last one, universal op amp 2, and I will place it. Before that, I can rotate or mirror it the way I like, and I will put it here. Now I need two voltage sources as the power supply of this op amp. So I will go to the components and search for voltage, and I will pick this voltage source. I need two of them, 1 and 2, and then I will right click on these sources and set the voltage to 15. This one also 15 volt. Now I will connect these two sources in series with a wire from here. So let me connect this like this, and then I will take this ground or reference node and connect it to this point here with a wire like this. That means with respect to this ground, this terminal will be at positive 15 volt and this terminal will be at negative 15 volt. Now let me connect this positive end of the supply to this positive end of positive power supply end of the op amp, and this negative end of the supply to the negative supply end of the op amp like this. Now this op amp got its power supply. Now I will take two resistances and connect them in series like this, 1 and 2. They are already in series. Now I will take a wire and connect the output of the op amp to this end of the resistance, and from this center point between two resistances I will connect a wire to the minus input terminal of the op amp like this. Okay, and then this end, the other end of the resistances, I will connect it to the ground, common ground or reference. Okay, and then I will connect a wire here and another wire here. This will be the input of my amplifier and this will be the output of my amplifier. Now I will set this resistances by right clicking. I will set this as 1000 or 1 kilo ohm. This one also I will set to be the 1000 ohm or 1 kilo ohm. Okay. Now this circuit is exactly similar to this circuit, our positive gain amplifier, and we have taken this R1 and R2, both of them 1 kilo ohm. So the gain of the amplifier will be 1 plus 1 by 1, 2. Okay, and this is the input, this is the output. Now let me see whether it works or not. For that I will apply a voltage here and measure the output voltage here. So let me go to the components again and search for a signal generator. Okay, so this is a signal generator. I will take this and put it here. Then I will take a wire and connect this positive end to the input of my amplifier, and the negative end I will connect this to the ground. This ground you can connect, or if you want to make your diagram cleaner, you can take another ground terminal and connect it here. Then right click on the source and let me say set this amplitude to 1 volt, frequency whatever you like, maybe 100 hertz, etc. Okay, and my circuit is ready. Now let me run it. I will go to simulate and select run. Then in the transient I will set the duration of my simulation. So let me select this time as 0.1 second, 0.1. Okay, so now this circuit is ready to be tested. It is in fact running now, and you can see that the cursor has turned into a red probe, voltage probe, with which I can measure voltage. Now if I put this probe here at the positive terminal of my signal generator, that is the input of my amplifier, then you can see that this is how the voltage is changing with time. Okay, the amplitude is 1 volt and frequency is 100 hertz. Now let me touch this probe at the output of my amplifier, and you can see that this blue curve is showing the output voltage. You can see that the output voltage is double of the input voltage at each and every point of time. The amplitude of the output voltage is 2 volt, whereas the amplitude of the input voltage is 1 volt. So this way you can make an amplifier with positive gain, and in this case the gain is 2. Now by changing these resistances, you can change the gain of your amplifier. Next, in the same way you can make an amplifier with negative gain. So let me start with this op-amp already connected to plus minus 15 volt power supply, and after that I will take resistances. Let me rotate it. I will put one here, another here, and then with a wire I will connect the output of the op-amp to one end of this resistance. The other end I will connect to the minus input terminal of the op-amp like this, and this end I will also connect to this resistance, and from here I will keep a wire hanging out, another wire I will keep here hanging out. This will be the input of my amplifier, this will be the output of my amplifier. And yeah, this positive input of the op-amp is to be connected to the ground. Now you can take a wire and connect it like this to the ground, or if you want to make your diagram cleaner, take a separate ground node and connect it like this. Okay, remember that in a circuit, wherever we have same symbol like this ground symbol, all those points are at same potential. Same symbol, same potential. Okay, so my amplifier is ready. This is the input, this is the output. Let me now take a signal generator and connect it to the input. With a wire like this, and the other end I will connect to the ground. Like this. Okay, now the circuit is ready for testing. Let me go to simulate and click on run. Then let me set the time for simulation as 0.1 second. Okay. I forgot to set the values of these resistances, etc. So let me right click on this resistance and set the value to say 1 kilo ohm, 1000. This one also 1000. You can take different values depending on your need. Then right click on the source and let me set the amplitude to 1 volt and frequency to 100 Hertz. You can pick the value you like, and now I will click on run. So the circuit is already running, and now if I touch this input terminal with the voltage probe, you will see this oscillating sinusoidal voltage with 1 volt amplitude. And now if I touch the output end of the amplifier, you see the output is exactly negative of the input. Same amplitude but negative of each other. So this is an amplifier with gain equal to -1, negative gain amplifier. Now let me give you your assignments related to this experiment. I have shown you how to make amplifiers using op-amp in LTSpice. Therefore, now using amplifiers, you can make either a negative impedance converter or a gyrator circuit. You can use LTSpice or Simulink or your favorite circuit simulator application. Your first task is to make a negative capacitor. You know that if I have a capacitor with capacitance C and the voltage across it, if that is VCT, with left side plus and right side minus is the reference polarity, and the current ICT in the direction from left to right, then you know that we can write a phasor relationship between this voltage and current in steady state in AC circuits, which will be like this: VC phasor voltage with left side plus right side minus is equal to IC phasor current flowing from left to right multiplied with 1 over j omega c. So the impedance is 1 over j omega c, which has a magnitude 1 over omega c and angle minus 90 degree. Okay, now if I draw the phasor diagram of this voltage and current, then if the voltage is here VC, then the current should lead the voltage by 90 degree, like this. This is true for a normal capacitor. Now for a negative capacitor, the impedance will be minus of this 1 by j omega c. So that will have a magnitude 1 over omega c, just like the normal one, but angle will be plus 90 degree. So for a negative capacitor, if this is the voltage phasor, then current will lag the voltage by 90 degree. This is somewhat similar to a inductor where current lags the voltage by 90 degree, although the magnitude of the impedance is inversely proportional to the frequency, just like the normal capacitor. Now you can use this idea to make a negative capacitor, or in your manual you will find a similar idea, very similar to this. A slightly different circuit is given. You can try to understand that circuit also. If you know op-amp, then you can do that. Otherwise you can use this idea, and you have to make a negative capacitance converter. Let me show you one that I have made here. Basically this is an amplifier with gain 2, and this is a capacitor. Now this is the input. So this part you can think as the negative capacitance circuit, and these two are the two terminals of my negative capacitor, which is here, and between these two terminals I have connected a voltage source. Okay, and let us see how it works. So let me run it. So this is running. Now if I hold this voltage probe at this point, then you will see the voltage, which is like this. Now suppose I want to measure the current that flows in this path from here to here. Okay, to measure that current, take your cursor on top of the voltage source, and then your cursor will turn into a current probe, current meter or current sensing device. Okay, and you will see there it is indicating a downward arrow. So it will measure current in the downward direction. Now let me click, and this blue curve shows the current waveform. Notice that this current is in the downward direction. However, if I want to measure the impedance of this circuit, I should measure the current in the upward direction, because the reference polarity of my voltage source has plus terminal upside and minus terminal downside. However, by default, LT Spice is measuring current in the downward direction, while I want to measure it in the upward direction. No problem, I will just take the negative of this. So here we can see that the green curve is the voltage, and if you take the negative of this blue curve, which will look like this, follow my cursor, the current will be like this. If you take the negative, then you can see that this current is lagging the voltage by 90 degree. But for a true capacitor, current should lead the voltage. So therefore, this is a negative capacitor. You should also change the frequency of your source and check how the current changes with different frequency. That means how the magnitude of this impedance changes with frequency. Do that study, that is your homework, and submit that as an assignment. After that, this is your second task and the last task in this assignment, to make an inductor using a capacitor and a gyrator circuit. So make an inductor with a capacitor without using any inductor. Now here we have shown you how to make a gyrator using amplifiers, and you can make amplifiers with op-amps that we have shown. So make a gyrator circuit like this, and then you can turn a capacitor to behave like an inductor. Okay, let me show you how it works. So this is my arrangement. This part is the gyrator. This is one side, one port of the gyrator. This is another side or another port. Here I have a capacitor. Let me zoom in so that you can see. Here I have a capacitor, and these three parts are basically three amplifiers. Now this generator circuit is slightly different from the one that I have described here. I mean here, because I told you that you can achieve the same functionality in multiple ways. So you can make your own circuit that will be highly appreciated. Also, when you make this circuit, remember that this amplifier with gain -2 should not be made with this particular structure alone, because then it can draw current from the input. Rather, you can take a cascaded combination of this positive gain amplifier and this negative gain amplifier, like this, with gain equal to +2 and -1 respectively. So here we have to make it -1 preceded by another amplifier with gain 2, but we can also do another thing. Instead of using this amplifier, we can take this input from here. You see, let me remove this connection and let me take this input from here. Okay, so already voltage is doubled here, and then you multiply with -1, so effectively we will get an amplification with a factor of -2, and then no current will be drawn from here. Okay, this amplifier can draw current, but that will come from the output of this amplifier. That is not a problem, as long as no current is drawn from here. Okay, this is the circuit. Now in your manual, in your lab manual, you will also find another circuit using op-amps, which you can understand if you know about the op-amps a bit, not very difficult. You can implement any generator circuit you like, the one in your manual, the one I have here, or the one I taught you here, anyone, or even better if you make your own generator circuit. Okay, then you simulate this. Let me show how my simulation works. So let me, so here I have the capacitor, and here I have a voltage source. So this arrangement, that means everything other than the source, everything here together acts like a inductor, and this and this, these two are the terminals of my inductor, where I am applying a voltage, and I will measure the current to check whether it is behaving like an inductor or not. Okay, so let me go to simulate and run. So this is working now. Let me first touch this wire with this voltage probe. Then you can see the voltage, and then to see the current you have to bring your cursor on top of this element, the source, and you see it has turned into an ammeter, but it is showing a downward arrow, so it will measure current in the downward direction. However, once again, I actually want to measure the current in the upward direction. Anyway, so I have to take the negative of what LTspice will give me. So let me click on this, and this is the current in the opposite direction. So I will take negative of it. Okay, and if you take negative of it, that will look like this. Follow my cursor. And then you can see that the current is following this voltage, and it is lagging the voltage by 90 degree. So that means this circuit here between these two terminals behave like an inductor. Okay, now to be more sure that this is really behaving like an inductor, I should change the frequency of this supply voltage and measure how the amplitude of the current changes with the frequency. That means how the impedance of this circuit changes with the frequency. If it is really behaving like an inductor, then the impedance of this circuit should be proportional to the frequency. So vary the frequency and check that yourself. That is your second task. Okay, do these two homeworks and submit the report within 15 days, and make sure that your report is handwritten. Printed report will not be accepted, and we will provide you a template. What are the things that you should put in the report, like circuit diagram, tabulations, etc. Follow that template, but write the report by hand. Do not use printed reports. Do not submit printed reports. Okay, and you can use any circuit for the gyrator and negative impedance converter, either the one that I have taught now or the one that is there in your manual. And I will come back with another video on this experiment, which will be slightly advanced, which will require a little bit of knowledge of op-amp, which you may skip for now if you have not studied op-amp yet. Thank you. Bye.